third chapter, 15th sessions. Grouping of cells. Grouping of cells. You are connecting more than one cell and you use it as a battery. Connection of cell, we call it as a battery. First one is the series combination of cells. Okay. Hear it. Series combination. Suppose there are n identical cells, right? How? N identical cells of EMF E and all, internal resistance R and all, connected to a an external resistor. Sorry, the picture is wrong. Connected to an external resistor R. So n cells, n identical cells connected in series. N identical cells connected in series to an external resistor capital R. Now when connection is series, when negative of that cell connected to the positive of the other, negative of that connected to the positive of the other, like that. So in this situation we add the EMFs to get the total EMF. So if I take this as a single cell, effectiveness, it will have an EMF NE, and all these resistors are just like series resistors. It will be NR connected to an external resistor capital R. That's it. So current will be drawn from positive to the negative. So what is current? Current will be effective EMF NE by effective resistance. So you take the current, that current will flow through this external resistor, the same current will flow through this effective resistor. So this effective resistance, effective internal resistance and external resistor connected in series. It's not parallel. You may be seeing like they are drawn parallel. It's not parallel actually. The same current flow through both. Same current flow through both. So we say it is series. So the effective resistance will be NR plus R. So I is equal to NE divided by NR plus R. This is the equation for the current. And there can be different cases. There can be case 1. Case 1 is when the external resistor is much greater than the internal resistor. When external resistance is much greater than the internal resistor, you can neglect this value. So current I will become NE by R. That is N into E by R. Actually, what is E by R? E by R is current due to one cell. So current is equal to N into current due to one cell. So what happens? Here the intensity of the current is increased by connecting more cells in series. So you have to opt series combination of cells to increase the intensity of current when the external resistance is much greater than the internal resistance. So that's the case 1. Next is the case 2. In case 2, suppose you have R less than small r or much less than small r. This situation is very rare to happen. Anyway, if it happens so, I will be equal to NE by, we neglect this term, NR. So N and then N and L will be cancelled. So this will be equal to E by R. So I equal to current due to one cell. Current due to what? One cell. So even though you connected N cells, it is not of use. The current obtained is current due to one cell only. So series combination of cell is opt when external resistance is much greater than the internal resistance. It's a very important information to understand about. Okay, that's about series combination of cells.